So video 4.3, we're looking at bond yields, but in particular, the yield to maturity measure of a bond yield. So this is the formula for a yield to maturity measure. There are different formulas that you can get for the yield to maturity measure of a bond. This is just one of them. Now, the key thing I wanted to focus on here is how the yield to maturity formula can produce a negative yield. Now, I'm not interested in you calculating these yields. I would never ask you to do that in the final exam. So don't worry about figuring out how to use this formula. If you want to, yeah, go ahead, feel free. But there are plenty of websites that give you practical examples of calculating the yield to maturity of a bond. So plenty of information out there. I wouldn't use this formula. There's probably more convenient formulas to use if you really want to become familiar with this yield to maturity measure. But that's not what we're interested in this course. We're interested in how can you get a negative yield on a bond? That is a negative interest rate. Now, in the previous, one of the earlier videos in this topic 4, I went through and explained why the simple current yield can't be negative, because you would need a negative coupon, which just makes no sense at all. But if we then move to the yield to maturity measure here, I'm going to use a very simple example to get the idea across of how the yield to maturity measure of a bond yield can be negative. So basically, the yield to maturity measure measures the return that you will get if you buy the bond now and hold it to maturity. Okay, compare that to the current yield, which is the yield that you would get if you held the bond for any given year. If you held the bond for a year and received 2 coupon payments of $30,000 each, and for a total of $60,000, and you paid $1 million for the bond, then the current yield would be 6%. So the current yield kind of gives you an idea of the yield over the course of a typical year of holding that bond. Whereas the yield to maturity, just as the name suggests, to maturity, gives you an estimate of the return that you can expect if you buy the bond today and hold it for the rest of its life. So what I've got here is a very simple example of, and in this example, I'm not going to calculate the yield to maturity. I'm going to intuitively explain to you how that yield could be negative in certain circumstances. Most of the time, the yield to maturity measure will be positive, but sometimes it can be negative. Okay, so what we've got here is a 5-year bond with a face value of $1 million, but we're assuming that you've purchased this bond for $1.2 million at the start of the 3rd year of the bond's life. And now you're holding it to maturity. Now, it doesn't matter that you may not want to hold it to maturity. This particular measure assumes that you do. Okay, so it really would only be an appropriate measure if you were buying a bond and intending to hold it to maturity. Then it would be a very accurate indicator of your expected yield. But if you were just buying it and holding it for 1 year, then perhaps the current yield might be a better measure for you. So it depends upon which measure you use, depends upon how long you're going to hold the bond. Okay, so we've got this bond that I've just explained. The bond pays a yearly coupon payment of $40,000. Now, as a lender, this is your cash flow if you hold it to maturity. So you're paying out $1.2 million at the beginning of year 3. So I've got a negative sign indicating that money is leaving your bank account. Then we've got 3 coupon payments coming to you, so positive numbers of $40,000 over the rest of the life of the bond. And then when the bond matures at the very end of year 5, you get the face value of the bond, that is $1 million back. Now, if we plugged all of these values into this formula, we could actually calculate the yield to maturity. But just looking at it, you should be able to see why this will give you a negative yield. So ignoring the complexities of this formula, you can see that what you've done over this 3-year period is you've purchased a bond for $1.2 million, and then what you've received back is 1 million plus 3 times 40,000. So you've received back $1.12 million. So you've paid out 1.2, but then you've received back over the life of the bond 1.12. So that's actually, you've paid out more money than you've received back for the bond. So in that sense, this bond that is priced for 1.2 has a face value of $1 million and pays out these coupon payments. If you bought this bond, it would have a negative yield to maturity. Now, of course, we could use the formula to calculate what is happening in this example on the bottom of this slide, calculate the yield to maturity as a percentage, but I'm avoiding doing that. I just don't want to go down that path of starting to calculate yields to maturity as a percentage value. But what I am doing is just motivating the point that you can get this negative yield when the net income flows associated with holding this bond to maturity are negative. So typically these bonds will become, bonds can have a negative yield using the yield to maturity measure when bond prices are pushed up so high that the high price you pay more than offsets the expected income flow coming to you over the rest of the life of the bond. And the expected income flow coming to you over the rest of the life of the bond would be the remaining coupon payments and the face value of the bond. So when these bond prices get pushed much higher than the face value of the bond, so high that they actually offset the coupon payments that you are getting. So when the bond price at the start of year 3, when that gets pushed up so high that it offsets all of the coupon payments, so that overall your return is negative, then you'll have a negative yield to maturity. So this bond might have a negative yield of, say, minus 1.2%, for example. So the cash flow is negative. So you've paid out $80,000 more than you get back, but that is ignoring the time value of money. So that's not a very good way of sort of considering this issue, because you're ignoring the time value of money. But as I said, a use of this formula might come out with would come out with a percentage yield, a yield to maturity in percentage terms. Okay, so as I said, the yield to maturity on this purchasing this bond at the start of year 3 and then holding it to maturity at its redemption date at the end of year 5, the yield might be minus 1.5% or minus 0.7%, something like that. Okay, so even though the simple current yield would be 40,000 divided by 1.2 million, that would be a positive yield. The yield to maturity would be negative in this case.